afternoon, my name is Francheska Iñiguez, and together with my partner Jose Zapata, we have the project Internet of Things Standardization Platform, HayIoT version 2. New measuring devices and IoT applications generate fast, real-time data, yet interoperability and visualization standards are lacking. Furthermore, we propose a platform to standardize data from all IoT devices, creating an efficient storage and visualization framework. For this reason, we have as general objective of our project to develop an integrated system that employs a standardization approach in order to simplify the monitoring of sensor data. The methodology involves phases to standardize and unify IoT modules and sensors. Initially, the modules are set up in the project environment to collect variable data. The data is transmitted using the MQTT protocol. Then an API is created to standardize data from various IoT sensors. It uses two protocols. The first one is MQTT for bidirectional communication and HTTP for data transfer. The sensor data is logged in a PostgreSQL database via the API, including a unique sensor identifier and a JSON field with the sensor data model aligned with the project Haystack's tagging standard. Among the results we have from the implementation of the project is a platform already running in which you can see three tabs. The first one allows to observe a graph with the sensing data of each sensor. The second one allows to register entities such as space, sensor, and site. And finally, the Entities tab that allows to observe all the registered entities. This is the first tab where you can write the name or ID of the sensor, and a list will appear with the sensors that match the above mentioned. It shows the sensor ID, site, space, type, description, and also an option to edit the sensor.
To be able to send data to our API, the user must have a sensor ID. This is obtained by registering a new sensor. For this, three forms were created to carry out the registration, which are site, space, and sensor. It should be noted that in order to register the sensor, it is necessary to have a site and a space created. In case of having a space, site, or sensor created, they can be viewed in the Entities section. The user will have the ability to delete the registration entities simply by entering a security key that was created for the user. At the beginning, we were working with traditional MongoDB. However, the response time and the amount of users that the system code process was not optimal. This is reflected in the graphics by the blue lines. To solve this problem, it was decided to move to time series data of MongoDB. In addition to this use, Windows time according to the amount of data requests in the dashboard, achieving a lower amount of response time and a rated number of users. By conclusions, optimal integration and simplified access to collect data, facilitating interoperability and data analytics. The choice of communication protocols provides great flexibility, enabling effective communication with a wide variety of IoT devices. The graphical interfaces has been designed with the user experience in mind, providing an intuitivity and user-friendly interface for accessing and visualization data. For recommendations, ensure the implementation of security mechanisms to protect data integrity. Establish a proactive monitoring system to monitor device status and platform performance. Feature lines. Explore the incorporation of artificial intelligence and machine learning techniques for the analytics and detection of patterns in the data collection. Continue to develop new functionalities and features in the graphic interface, such as customized dashboards, real-time alerts, and advanced visualizations. Thank you.